So, all day today we're going to be making equations that start y equals k. Y equals k. What was it? Constant to variation. Thank you. K is going to end up just being a constant, a number. But k is what kind of makes all these equations work out, because you can't just set up y equals x or something like that every time. You need something to make your equations different. That's where k comes from. Now, you're going to start every one of them like this. Now, when you vary directly, whoa, yeah, people at home are going to be thinking, what the heck? You had to come to class to appreciate this picture. Okay. Use the four-step procedure for solving problems. When you vary directly, that means the things are directly connected, and you're going to use multiplication. So this is how you would do number one. Y equals k, and when you see directly, whatever it's directly as goes here. Y varies directly as x, boom, times x. There's only three different things you're going to see today. Y varies directly, which is multiplication. I'm going to come back to this slide in just a second. Y varies inversely. Now, if directly is multiplication, what do you think inversely is going to be? Division. Y varies inversely. And then y varies jointly, which just means it'll be multiple variables, all that are directly. Like, it'll say jointly as x and z. So that's just multiple variables. And that's really everything for today. Directly means multiplication, inversely means division, and jointly means multiple directlies. It won't always be x or z. It might say y varies directly as the square of x. Or it might say y varies directly as the inverse of the square root of x. Or y varies directly as the cube of x and the square of z. But regardless, you just put that either in multiplication or division. Now, back to these. Let's just set them both up, and then we'll come back and solve them. Y varies inversely, so what do I do with my x? Divide it. Very good. Now, all of these problems, here's the hard part. Setting up the equation. Once you've got that, it's all downhill. They're going to give you two sets of data. One is going to give you everything but the k. Regardless, it might give you 5 different variables. It won't, but it could. But the first set is it's going to give you everything but your k value. And you're going to use that to solve for your k. So let's do that part first. Number one, y varies directly as x. Y is 65. X is 5. So that's 65 equals k times 5. Divide, and what does our k equal? 13. Now you're going to rewrite your equation. Y equals 13 times x. You have solved for your constant of variation. Here is your new equation. That's the whole point of the first set of data, is to give you your k value. Now you plug in the second set and solve for whatever they want. Find y when x is 12. Okay, y equals 13 times 12. Multiply, and then was 1, 5, 6. Yay. Boom, done. Set them up. Plug in the first set of data for your k, and then plug in the second set to find whatever it asks for. That's like the entire lesson, but we'll do more examples. You plugged in 65 and 5, boom, boom, and solve for k. So let's try number 3. Y varies inversely. Y is 12, x is 5. So what do? Multiply. That'll give me k is 60. So my new equation is y equals 60 over x. Then it says find y when x is 2. So 60 over 2 is, and there's your y. They really don't get any more complicated. The only thing it's going to throw in is it'll say something as like the square of x, so you have to put like x squared, and then they're going to throw in jointly, which is just multiple little multiplications. And that's it. All right. And I am going to give you a word problem or two today. because they're not going to be any different. I thought it'd be fun. And it will be. It'll be very fun. Okay, next slide. Boom! Let's just set these suckers up real quick. Number 5, y varies directly, which means I am multiplying, as x, and inversely as the square of z. So what do I do with z squared? Divide, because it's inversely. Very good. We're just setting them up right now. Number 7, y varies jointly as x and z. What does that mean? Multiply, multiply. Jointly as x and z. Boom. Number 9 looks fun. In fact, I want you all to read number 9 and see if you can come up with it, and then I'll take a volunteer. If you got it? Right. Very nice. That's exactly right. Jointly as a and b, and inversely as the square root of c. Very nice. So the setups are done. All the rest of us just plugging in numbers like you've been doing since you was a wee lad or lady. Yes, never mind. Okay. Number 5. So it says x, oh, here it is. Y is 20, x is 50, and z is 5. Y is 20, x is 50, and z is 5. Feel free to simplify this or solve this any way you wish. Like, I might prefer to reduce that to 10. You might prefer to go ahead and multiply it by the 20. Whatever, doesn't matter. Do it any way you want to. I'm going to go ahead and reduce. Here. Touche. I did not see the squared. Thank you for correcting me. So that'd be 2k. Divide, and what is that, 10? Thank you for catching that. So that's my new equation. Y equals 10x over z squared. Let's see, then you plug in 3 and 6. And you can reduce 30 over 36. It'll probably just be a fraction. 30 over 36 is like 5, 6, I think. Click, click. Is there another one on this page somebody would like to see worked? Or do you have a question about anything we've done? Once you got the setup, they're all going to solve the same. Yes, ma'am. Number 9. All right. Here we go. Let's see. Y is 12. A is 3. B is 2. And C is 25. So that's 12 equals 6k over 5. Multiply by the 5. Gives you k equals 10. Plug that back into our original. So that'll be y equals 10 times a times b times over the square root of c. And you can plug in your second batch of information. A is 5, B is 3, and C is 9. If I'm not mistaken, these are just going to cancel. And you're left with 50. Questions about that? No? Alright, let's look at one word problem, then I'll cut you loose. The height that a ball bounces varies directly as the height from which it was dropped. A tennis ball dropped from 12 inches bounces 8.4 inches. from the height. From what height was the tennis ball dropped if it bounced? All right, so the height that a ball bounces varies. So height varies. So h equals, or you could use y if you still wanted to, but I think it's easier to keep up with the variables. Varies. You're always going to use k directly as the height from which it is dropped. So I'm going to call this the drop height. The height that it bounces. So I'm going to call this the bounce height, I guess. The bounce varies directly as the drop. The key here was directly. So regardless of what letters you used, you should have just had things being multiplied. So, dropped from 12, bounce, oh, oops, that's the drop height. Dropped from 12, bounce is 8.4, solving for k. Divide. Somebody gonna divide that for me. 0.7. Boom! I'm on fire today. Thank you, Jake. Punch that back in. And from what height was the tennis ball dropped if it bounces 56 inches? 56 equals 0.7 times d. Divide. Feeling froggy today. I'm just going to take a victory lap after this. Inches. So we just divided 56 by 0.7. Questions? We're already done. Yay. Here's your assignment. You may cut off the second portion here. The second part's review, starting to prepare you for tomorrow's review and Wednesday's test. No, I won't. I don't want to freak people out any more than I already do on a daily basis. Jessica, if you would, just write something on there as a reminder that, so I don't think you just skipped it.